Did you know that L'Hopital's rule is a waste of time on this limit problem? I'm going to prove it to you by first briefly showing how we would normally use L'Hopital's rule, and then I'll show you my faster ninja method later on. For L'Hopital's rule, we have to first prove we can even use it, right? You would plug in 0 for x wherever you see the variable in the original limit, and after you simplify this expression, you would get the indeterminate form 0 divided by 0, which tells you that yes, you can use L'Hopital's rule. Now hang on a second, because what you're going to notice now is taking the denominator and numerator's derivatives for L'Hopital's rule. When you start with the numerator, it looks easy, right? This one is just the chain rule, and it's very easy to give it an eyeball test. You get 4 cosine of 4x. But the denominator takes a little bit more work because you have to use the product rule, and then finally you're going to have to simplify some terms at the end. Now it doesn't seem bad, but you want to save your exam time, right? So let me show you my faster method now. What I'm going to do is take the original fraction for the limit problem I gave you, and I'm going to split it up into 2. And the reason why I'm doing it this way is I carefully chose each part because the left part should look very familiar, like the squeeze limit theorem you've learned. We know the limit as x approaches 0 of sine of x divided by x converges to a 1. But how do we deal with this 4x here? And wouldn't it be nice if we had it on the bottom? Well, what if I told you that you could just simply add an extra term, 4x divided by 4x? Because now we have extra stuff we can play with, and we can actually swap these two terms now and move the 4x over underneath the sign of 4x, so that this left expression here looks like we could use a squeeze limit theorem. But hang on a second, because we can't just split this up as a product of 3 separate limits yet, because we have to prove that everything to the right here converges first, right? Well, first of all, let's go ahead and get rid of that 4x divided by x. And then now we need to prove, does 4 divided by cosine of 7x converge to a value when x approaches 0? Well, let's try plugging in 0 directly for cosine of 7x. You would get cosine of 0, which is a 1, right? So 4 divided by 1 absolutely converges. So if that converges, and this left part converges using the squeeze limit theorem, we can now actually solve this directly as 4 divided by cosine of 0, giving you this final answer.